All right, we are going to be starting Unit 9. Unit 9 is all about solving quadratic equations. We're going to be learning a couple different methods for solving quadratic equations and then kind of what method is best to use in which case. So the first lesson we're going to cover is 9.2, which is solving quadratic equations by graphing. And this is really similar to the topics we talked about in the last chapter. We talked a lot about how the x-intercepts are your solutions. And so that's one way to solve quadratics, is to graph it and look at those x-intercepts. We can have three types of solutions. So we could have two solutions, and that would be when we have a graph that has two x-intercepts. So your parabola crosses twice. You could have one solution if the vertex of your graph is your x-intercept, so it's only really crossing once. And you could have no solution if there is no x-intercept, so your parabola is above it and opens upward, or below and opens downward. That would have zero solutions. So those are sort of our three possibilities. So we're going to be looking at four examples to go through these. So in the first one, we have x squared plus 4x equals 0. So these are in standard form, so we're going to start by taking our axis of symmetry, so negative b over 2a. So that would be negative 4 over 2 times 1, which would give us negative 2. When we substitute that in, we would have negative 2 squared plus 4 times negative 2. That gives us 4 minus 8, so negative 4. So we would have our table. We can set up our vertex is negative 2, negative 4. So our table, we can complete negative 3, negative 4, negative 1, and 0. If we substitute negative 1 in, we would end up with negative 3. If we substitute 0 or negative 4 in, we would end up with 0. So thinking about graphing this, we would have the coordinate negative 2, negative 4 is our vertex. And then we have negative 3, and negative 1, negative 3, 0, 0, and negative 4, 0. So the parabola looks like this. We have two x-intercepts at 0 and negative 4, and so those would be our solutions. X equals 0 and negative 4. So this is the case where we have two solutions. Example 2, we have negative x squared equals negative 2x plus 1. We want to make sure everything's on the same side of our equation, so we could add the x squared to both sides. So we get 0 equals x squared minus 2x plus 1. Okay, again, this is in standard form, so to graph, we're going to take negative b over 2a. So this would technically be negative 2 over 2 times 1, which would give us 1. When we substitute 1 squared minus 2 times 1 plus 1 into our original equation, that leaves us with 0. So we would have our table, 1, 0 would be our vertex, and then we can do 0, negative 1, 2, and 3. And then we'd substitute all those values in. Both 2 and 0 are going to give us 1s. Both x values of 3 and negative 1 are going to give us 4. Alright, so plotting this, we would have 1, 0, 2, 1, 0, 1, 3, 4, and then negative 1, 4. So this is a parabola opening upward. The vertex is on the x-axis, so this has one solution, and that solution would just be x equals 1. Our next example, we have x squared minus 5x plus 4 equals 0. So again, we're going to start with our vertex and axis of symmetry, so negative b over 2a. That would give us negative 5 over 2 times 1, which would be 5 halves. When we substitute that in, we would have 5 halves squared minus 5 times 5 halves plus 4. This would give us 25 fourths minus 25 seconds plus 4. We can get all common denominators, so we could say 25 fourths minus 50 fourths plus 16 fourths, which would give us negative 9 fourths. Okay. We talked about this case in class because we have a decimal. We don't necessarily want to have decimals for the rest of our table, so we could just go to 2, that's a difference of half. So again, if we go a difference of half, that leads us at 3, and then we could go 1 and 4. Substituting in 2 and 3 gives us answers of -2. Substituting in 1 and 4 gives us answers of 0. So plotting that, we would have 2.5, -2.25, so right about there. 2, -2, and 3, -2, and then 1, 0, and 4, 0. So we have a parabola opening upward. We have 2 solutions, and those are x-intercepts, so 1 and 4. All right, our last example, we're going to follow the same process. Looking at our axis of symmetry, -b over 2a, we would have -2 over 2 times 1. That would give us -1. When we substitute that into our original equation, that's going to give us a value of 3. So our vertex would be -1, 3. We can finish off our table with -2, -3, and then 0 and 1. 0 and -2, when we plug them in, will both give us answers of 4. 1 and -3 will both give us answers of 7. So when we go to plot this, we would have a vertex of -1, 3. And we'd have -2, 4, and 0, 4. 1, 7 would be a little bit off the graph. And -4, 7 would be a little off the graph. So in this case, we have a parabola that's above the x-axis and it's opening upward. So this would be a case that has no solution. Okay, so this method to solving quadratics is by graphing. We're going to learn a couple other methods throughout this chapter, but make sure for the assignment that you're using the graphing method to solve these.